Crowberry bog. And so as I'll demonstrate, the site has significant conservation value, and I'm going to discuss some research we initiated back in 2016 and also talk about the implications that work has for identifying management issues. This always happens on my first slide. There's a delay. There we go. So before I get started, I just want to acknowledge others on our research team, my colleagues at DNR and Colorado State University. And although we didn't have explicit funding for this research, DNR and CSU did support the time we spent on the project. And so we really appreciate that support they provided. So I'm guessing most of you have an idea of what a bog is, and maybe even thinking this might be a silly question to lead with, but there's actually a wide range of bog definitions that are used in various disciplines. And so I want to outline the definition that most peatland ecologists use. And first, a bog is a peat-forming wetland, also known as a peatland. And peat is the accumulation of relatively undecomposed plant material. And bogs are just one type of peatland. Northern peatlands are often categorized into two kinds, bogs and fens. And fens are considered ombrotrophic peatlands because they are supported by groundwater and to a lesser degree surface water, which generally pick up mineral ions as they flow through soils and make contact with bedrock. The types of bedrock and soils that water does come in contact with dictates the water chemistry of those peatlands or of those fens. In contrast, bogs are called ombrotrophic peatlands. In other words, they are rain-fed. Precipitation is the dominant source of water and nutrient inputs into the bog. Because precipitation generally has low pH and low ions, it follows that the bogs are also acidic and have low nutrients. Ombrotrophic conditions can arise in a couple of different scenarios. One example is where peat accumulation raises the peat surface above the influence of groundwater and surface water, and that's demonstrated here. I might put my laser on. In this upper graph, and that's generally, again, called a raised bog. And another example is when low hydrologic conductivity of peat prevents groundwater flow from reaching certain peat layers, and effectively that restricts water inputs to those layers to be from precipitation. And that type is shown here in the lower graph, and that has been referred to as a flat bog. So what about Washington's bogs? The term bogs is used to describe many wetlands in the state, but are they ombrotrophic? So far, up to this point, no Washington bogs have previously been shown to have a conspicuously raised surface. At best, Washington bogs were thought to be flat bogs. And despite the public interest in bogs in the state, there were no published data demonstrating whether they were ombrotrophic. Washington bogs have historically been classified as bogs simply based on their vegetation composition. The problem, though, is that bog-like vegetation can occur in those fens I was talking about, acidic fens. And so the only way to know for certain whether a site is ombrotrophic or rain-fed is to couple that vegetation information with hydrochemical data. So this brings me to our study site, Crowberry Bog. In 2011, I was conducting surveys of rare and high-quality wetlands as part of an EPA-funded project. And Crowberry Bog was one of the sites I was visiting. And after I was trekking from the bog's edge to the center, I noticed that I had walked uphill. The center of the bog was clearly higher than the edge. And so I immediately recognized that the site could be very significant. And so the raised nature of Crowberry Bog was strongly suggestive that the site could be ombrotrophic. And then, of course, raised. And raised bogs had not been previously recorded in Washington nor anywhere else in the western contiguous US. So knowing for certain whether Crowberry is ombrotrophic was important not only to determine its conservation value, but also to help guide long-term management of the bog. Mainly, how do we manage the bog's hydrology? And so at that point, I knew we needed to investigate the site a bit more closely. And so I reached out to Dr. David Cooper at Colorado State University to let him know what I thought I'd found. I knew David from my time that I spent in Colorado, and he studies peatlands all over the world. So I knew he'd have interest in my observations. But he initially didn't believe me because everyone kind of knew that these bogs just didn't occur in the Western US. But I kept pestering him, and he finally decided that he needed to see the site, and he made his way up here to see the bog. And so David brought a few of his colleagues from CSU in April 2016, and in collaboration with them, we developed 4 research questions to determine whether Crowberry was ombrotrophic. And those questions were, is topography raised above the adjacent land area? Are there significant periods of the year when groundwater movement is primarily downward through the bog? Are the concentrations of pore water ions within the range reported for ombrotrophic peatlands elsewhere? And is vegetation composition limited to species tolerant of nutrient poor conditions? So first, I want to start with a quick review of the study area. Crowberry is located on the Western Olympic Peninsula in Jefferson County. Peatland occurs on our Fraser Age Glacial Terrace just south of the Hoh River and is 19 hectares in size. The site is approximately 135 meters above mean sea level and 18 kilometers east of the Pacific Ocean. July and August, warmest months, December through February, the coldest, and most precipitation is falling between October and March, while July is typically the driest month. So to address our research questions, we analyzed LiDAR data to determine the bog's topography. We installed data loggers in shallow wells to measure hourly water table depth and installed a series of piezometers next to each well to determine water movement. And then we collected water samples from those shallow wells 4 times per year and analyzed them at the CSU Analytical Laboratory. And then we assessed vegetation composition by establishing 100 square meter releve plots around each well and identified vascular plants and dominant mosses and lichens. So the LiDAR-derived digital surface models revealed that the bog has a distinct raised form in both the north, south, and east-west directions, which you can see on this slide, the graph on the right. The LiDAR also demonstrated that the site has 3 ecological zones that have been reported in other raised bogs. That first zone is called the lag, and that is the outermost zone. And this is essentially a mixing zone of waters that drain off the bog, as well as from adjacent upland and wetland areas. The upward sloping margin is called the rand. And then the bog center, which is relatively flat at Crowberry, is called the plateau. And at the highest point, the elevation difference between the plateau and the lag is nearly 3 meters. A peat core from a study in the 1970s from this site showed that the plateau is composed of sphagnum or peat moss derived peat that extends to a depth of 3.8 meters. That study also determined that the bog started to form around 15,500 years ago. And so these results collectively demonstrate that the bog is raised due to peat accumulation rather than some underlying bedrock protrusion or sediment deposit. So this hydrograph was generated from the data loggers in the shallow groundwater wells. And the top graph shows water table levels in each of those 3 ecological zones I mentioned, the lag, rand, and plateau. And then the bottom graph shows individual precipitation events. And then the horizontal axis here shows the dates of those precipitation events. And then these 2 graphs are in sync. And so first, 2 points I want to make with this graph. First is all this noise in the hydrograph is indicating that each ecological zone is very responsive to individual rainfall events. The second point is how deep each of these 3 troughs are, and that's during our summer dry season. After just a few weeks or even months of no rain, water tables drop 40 to 80 centimeters, which is really significant and unusual for where bogs typically form. And these results demonstrate that the maintenance of water table levels near the soil surface requires regular precipitation. And so I realize, so this graph in the lower left obviously is very busy and you're not gonna be able to digest much from the slide here, but the take-home message from the piezometer data, which again tells us how water is moving across the site, is that the hydrological gradient on the plateau is downward through most of the year, basically during the rainy season. And then in the rand, that sloping margin part of the bog, water flow was lateral. And so this demonstrated that, again, water is originating from precipitation, flowing downward through the plateau, moving laterally through the rand, and finally discharging into the outer zone called the lag. So rainfall originating from open ocean waters is high in both sodium and chlorine, i.e. salt, and these high levels are reflected in Crowberry Bog's water samples. So if groundwater was a dominant source to the bog, the abundance of these ions would be diluted and lower. And so the high levels of sodium and chlorine indicate the importance of precipitation inputs into this site. Calcium is also very low in precipitation and much higher in groundwater and surface water. And consequently, researchers, or because of that, researchers around the world have found that calcium concentrations less than 2.5 milligrams per liter is a strong indicator of a site being ombrotrophic. And that value varies a little bit by each geography, but nonetheless, that's a commonly used threshold. And you can see in this table here that Crowberry Bog's calcium concentrations are well below that threshold and well below those reported in mineral soil wetlands and Puget lowland bogs. So what about vegetation? Well, in a nutshell, the plateau and the rand support numerous species that are strong indicators of oligotrophic or nutrient poor conditions. And the distribution of different sphagnum species or peat moss species are a much stronger indicator of underlying ecological conditions than the vascular plants. And the story they told is strongly suggestive of ombrotrophic conditions or rain-fed conditions. On the plateau, there's a nearly continuous moss carpet of two species called Sphagnum fuscum and rubellum, which you can see in this photo here. As we move into the rand, a different species, sphagnum species dominates, and that is Sphagnum capillifolium. And that species is absent from the plateau. However, it also is an indicator of ombrotrophic conditions. In fact, it dominates many Puget lowland bogs. We think the difference there is related to the rand having lower water tables. And then the lag, that outer zone, is dominated by sphagnum species more typical of non-bog habitats. Vegetation structure was also distinct across these zones, as shown in the LiDAR-based canopy model here. Because of high water tables, the plateau is dominated by very short shrubs, and then also stunted trees such as shore pine and western hemlock. And many of these same woody species occur in the rand, but their height, vigor, and density are conspicuously greater, and again, presumably due to the rand having a lower water table. So our results demonstrate that Crowberry Bog is indeed raised and ombrotrophic, and in addition, the morphology of the bog and the ecological characteristics match those of a very restricted type of raised peatland called a plateau bog. And plateau bogs are limited to just a few areas in the world, which are shown here in the red circles. And essentially, these are places where a very strong maritime influence controls bog development. These locations have high precipitation, relatively long growing season, summer fog, and salt spray influence precipitation. And Crowberry also supports a few rare species. We have a rare sedge, we have 2 rare mosses, and a rare butterfly species that are found in the bog. So all these factors make Crowberry a very rare and significant part of Washington's natural heritage. Having confirmed that the bog is ombrotrophic.
Joe, sorry to interject, just you have about a minute to finish.
Okay. So having confirmed that Crowberry is ombrotrophic, we're now able to focus management attention on the most important drivers for maintaining the bog's integrity. Globally, the lag has been shown to be an extremely important functional component to bog ecosystems. The lag provides 2 critical hydrological functions. It is thought to at least maintain water levels in the bog. So water levels in the lag help control water levels in the interior of the bog. And also the lag serves to move water or excess water away from the bog. So as it flows off the plateau during the rainy season, it's helping move water away. And so because of its functional importance, a primary management focus on Crowberry Bog will be to ensure that the lag remains in proper functioning condition. So real quickly, the presence of roads around the bog's perimeter at Crowberry Bog pose potential threats to the lag's ability to function. The aerial photo shows general water movement, yellow arrows, and this is just based on our observations. We've not measured this yet. And the blue squares represent culverts and or road blockages. These 2 photos on the bottom show areas that are where water is being impounded due to the road. And then on the upper left, you can see this is a culvert. You can't really see it here, but during the rainy season, this thing is just gushing with water. And this is in the northwest portion of the bog. This whole area right in here is continuously inundated. In the summer, you don't see much water at all coming across here. And then on the north part, there's also an old road that we see water moving over it during the rainy season. we weren't able to find a culvert, but so we don't really know what kind of impact these restrictions may have on the bog. It doesn't look to be significant. These have been in place for 50 years, but this is an area of research that we really need to dive into. And then I'm going to go real quickly on these. Another potential management issue is tree encroachment. Looking at a series of historical photos, you can see that starting in 1939 to 2016, the amount of trees along, well, in this part of the plateau has increased, as well as along the outer transition zone between the rand and the plateau, trees have increased. And this tree encroachment is observed in bogs around the world. Some have correlated to climate change, others think it's cyclical. For us, again, we're at that southern extent of where bogs occur. So this could just be a natural dynamic that we see. You know, you would expect that maybe trees, there's always a tension between open and tree vegetation in this zone. It could also be a warming climate. There's been some studies that shown warmer winters allow more tree seedlings to establish in bogs. If the duration of those troughs expand in the summer, that could give them a competitive advantage, and that may be what we're seeing. But in summary, you know, the site is ombrotrophic. It's very significant from a conservation perspective. But again, we have more research to do on management issues. And if you'd like to learn more, we recently published our work in the journal Ecohydrology. It is open access, so you can access it at this link. And then, of course, you could always contact me if you have any other questions. And then finally, as I mentioned at the beginning, because of the significance of the bog, DNR protected the site as our state's newest natural area preserve. And so appreciate your attention.